Hey everyone, welcome to our explainer video on CDP Wallets version 2. If you're a developer looking to integrate cryptocurrency wallets into your applications, this video is for you. Today we'll dive into what CDP wallets are, how version 2 improves over version 1, and why you might want to consider using it for your next project. Let's get started. First things first, what are CDP wallets? CDP stands for Coinbase Developer Platform, and the Wallets API is a powerful tool that lets you programmatically create, manage, and use crypto wallets. Imagine you are building an app that interacts with the blockchain but without the headache of managing private keys or setting up blockchain infrastructure. Coinbase takes care of all that behind the scenes so that you can build amazing user experiences and focus on your app. So what's new with CDP Wallets version 2? Let's break it down by comparing it to V1 and highlight why these upgrades matter. There are some game-changing improvements across five key areas: security management, authentication, network support, wallet scope, and smart account. First, security management. In V1, you had to either manage your own keys, risky and error-prone, or deal with a complex multi-party computation setup. V2 simplifies this with a trusted execution environment setup using AWS Nitro Enclaves. This means private keys are generated and stored in a secure hardware vault, and transactions are signed there too, meaning keys never leave, not even to Coinbase or AWS. This means Coinbase handles key management securely, giving you the peace of mind to focus on building. Second, network support. V1 was limited to EVM-based chains like Ethereum-based networks, restricting your app's reach. V2 expands this by adding Solana support, letting you build cross-chain applications. This flexibility opens up multiple ecosystems, letting you reach a broader audience. In V1, you needed a separate secret for each account, which could get messy fast. V2 introduces a new single wallet secret that works across all your EVM and Solana accounts. This cuts down on complexity and makes credential management a breeze. Fourth, smart accounts. V2 brings native support for EIP-4337, enabling smart accounts. These are smart contract based accounts that lets you sponsor gas fees for users, do batch transactions, or set up custom spending rules. This enhances user experiences by making transactions smoother and more cost efficient. Fifth, wallet scope. In V1, each EVM wallet was tied to a single network. More hassle if you're working across chains. V2 lets one wallet operate across all supported EVM chains, reducing overhead and giving you more flexibility. With these upgrades, V2 expands your workflow, simplifies your workflow, boosts security, and expands what you can build all in one package. Curious about the tech? Here's the gist. CDP Wallets version 2 uses a trusted execution environment setup to keep your private keys safe. Think of it as a vault where your private keys are generated and transactions are signed, nothing gets out. As a developer, you can interact with it using the REST endpoints or the CDP SDK in TypeScript or Python. It's straightforward. Create wallets, manage addresses, and sign transactions all with just few lines of code. And now getting started is easier than ever. Just install the latest packages and you're good to go. So what can you do with CDP Wallets version 2? The possibilities are huge. You could build a trading bot that executes trades automatically based on market signals, or you could create an AI agent that sends payments or checks balances for users on the blockchain, or you could create automated mass payers for distributing funds to tons of recipients, or even create a DeFi or NFT platform using gasless transactions thanks to smart accounts. Whether it's payments or DeFi or something totally new, V2 gives you the tools to build securely and efficiently. Security is a big deal with crypto wallets. V2's TW handles the heavy lifting for key protection, but you've still got a role to play. Keep your API keys and wallet secrets secure. Follow best practices like storing them safely and restricting access. A strong foundation keeps everything safe. So before we get started, we need to get the API keys and the wallet secret. So you can get both of them from Coinbase Developer Platform's portal. Just go to portal.cdp.coinbase.com and log in or sign up there. So once you have done that, you will see your own dashboard. Just create a project over here and you can generate the wallet secret as well as the API keys from the dashboard itself. So once you have generated the project and generated the wallet secret and the API keys, you're good to go. Ready to start building, getting up and running with CDP Wallets V2 is super easy. Let's walk through a simple example that creates a wallet, requests tested funds, and sends a transaction in just one simple script. So let's get started. So first of all, you need to set up a JavaScript environment with the required libraries, that is the CDP SDK and the VM. This will allow us to interact with the blockchain and send transactions as well. So just go to the terminal and navigate to the folder that you want to create the directory in. So I am here on my desktop itself. So I'll just write npdir cdp wallets v2 demo. And just navigate to this folder. And so first of all, we need to set up the JavaScript environment. So for that, we just run the command npm init-y. So this will create a package.json for us, which will ultimately set up the JavaScript and the Node.js environment. So the package.json has been set up. Now let's install the dependencies as well. So we need to install the CDP SDK and the VM library so that we can interact with the blockchain and you create wallets, manage transactions, and do many more stuff like that. So I have the command over here. So we will install the Coinbase CDP SDK and the VM. So the SDK has already been upgraded to version 2. So anyone can use it and test it around as well. And that's it. We are done with the JavaScript environment setup and the installation of dependencies as well. Now we can move to the main script that would be main.js, which would set up the script for us, which creates a wallet, requests tested funds, and does a transaction as well. So let's move to that. So let's go ahead and create the main file, which would be main.js for us, which would have all the logic for the script. So I have main.js over here. Let's create it. And next we'll start with the imports, obviously. So we'll import all the packages necessary, which would allow us to create the script. So I already have the imports over here. Let's go through this one by one. So first of all, we have the CDP client SDK, which would allow us to create a connection to the CDP wallet API. Next, we have some utilities from VM, which would allow us to manage the blockchain interactions. And last, we have the base Sepolia utility from VM chains, which would specify that this script is supposed to be run on base Sepolia itself. So now let's set up a connection with the CDP Wallets API. So I'll just write over here const CDP is equals to new CDP client and close the brackets over here. And that should be it. Now we have set up a connection with the CDP Wallet API version 2. And now we can go ahead and write the rest of the logic as well. Now let's generate a new address using the CDP SDK. This would be the wallet which would be used for testing. Now I have the code over here. Let's just go through this once. So first of all, we'll create an account variable which would use the cdp.evm.create account to store the address. And next we'll console log it so that we can see this address publicly as well and note it down. So once you have run this script, so you'll see something like created account and your account address. You can note this down. So that's it. We have set up a wallet. Now let's move on to funding it. Since we are on base Sepolia, we would need testnet ETH to do something useful. So the CDP SDK has a faucet for this purpose. Let's request some funds from there. So we have the code over here. Let's go through this once. So first of all, we would import the cdp.evm.request faucet function from the CDP SDK. This would allow us to request the faucet from the CDP SDK's faucet. This would take three main parameters. One would be the address, account.address. So the address which receives the testnet ETH. Uh, Second would be network based Sepolia, which is obvious. And third would be the token. So we would need testnet ETH. So we would specify ETH over here. So this would be the token that we need from the faucet. And last would be the console log. Basically, we would get the transaction link using the console log so that we can double check this as well once. Since the faucet transaction takes a moment to confirm, so we need to confirm the transaction before proceeding. Let's set up a public client with VM to handle this. So we have the code over here. So first of all, we'll set up a public client using the VM utilities. So we are on chain base Sepolia over here. So we will create a public client that connects to base Sepolia using the HTTP method. And next, we would use the public client dot wait for transaction receipt. So basically, this will wait for the transaction to get confirmed before proceeding to the further steps. And let's just do a small thing before, as this is a preliminary technique, so we need to move this to the start of the script. So I'll just move this over here. Yeah, this should be good. So we have got some tested it from the faucet, and now we can use it to do some transactions. So we can use the VM's wallet client method to send some tested it from our wallet to another wallet. So first of all, we'll set up the wallet client. So So we have the wallet client method over here, and yeah. So let's go to this create wallet client method and what are the parameters that it's taking. So first of all, we have the account parameter. So we will use the CDP SDK account parameter over here, and we need to convert this CDP SDK account parameter into a format which VM can understand. So that's why we are using the to account method over here. Next, we have the chain which is base Sepolia and the transform method which is HTTP. Now we need a recipient address and the value as well, which we need to send to this recipient address. So uh, co- we have the variable which would specify the recipient address. So in my case, I have used one of my testing accounts. You can use any whichever you want. And next, we have the value parameter, which takes the amount of ETH that you want to send to the recipient address. So in this case, we need to use a function known as pass ether, which would convert your amount to the smallest unit of ETH, which is way. And yeah, now we can send the transaction. For sending the transaction, we'll use the wallet client send transaction method. So we have it over here. So we'll use the wallet client send transaction method, and it takes two main parameters. One is the to value, which would be the recipient address, and the value, which is the pass ether. And we have already specified the wallet client as well. So this would send the transaction, and then it would log the transaction link as well, which would be with the transaction hash. So we can double check this as well. Now script is ready to be executed as well. So before we move on to the script execution, we need to make sure that the environment variables are set up. So for this, you can just go to docs.cdp.coinbase.com's Kickstart for Wallet API version 2. And here you can see how to set up the environment variables and set up the environment. So first of all, we need to generate a CDP secret API key from the console and generate a wallet secret from the CDP console as well. And once these are done, once you have generated the CDP API keys and the wallet secret, you can just import it to your envs and set up the .env method in your script. So once that is done, you have already set up the envs and set up the env configuration in your script. Now it's ready to be executed. So we just run a node main.js over here. So I'll just make this terminal bigger. So we need to see two main functions over here. So one is the testnet ETH faucet transaction, and second would be the send transaction. So let's see if this was successful or not. So we have seen the requested, we have seen the testnet ETH transaction as well, and we have seen the send transaction as well. So let's cross check this once. So we go over here, paste this. So yeah, this was a successful claim function from the faucet, which gave us some testnet. Now let's see the send transaction as well once. And yeah, we were successfully able to send some testnet to the desired address as well. And that's it. We were able to set up a simple script which allows us to get us some testnet from the faucet and send a transaction using CDP API Wallets version 2. Excited about CDP Wallets version 2? It's fully open and ready for you to use today. Though keep in mind, it's still in alpha, so expect some exciting developments and potential updates as we refine it. Head over to Coinbase Developer Platform's website, install the latest packages, and build your next crypto-powered application. Whether you're building trading bots, AI agents, or DeFi tools, CDP Wallets API has everything for you to build securely and efficiently. For more results and tutorials, don't forget to check out Timelapse. They have got some great content to help you along the way. Also, subscribe to our channel for more crypto dev insights. Thanks for watching this and have a good day.